Right now, at this exact moment, your entire galaxy is drifting sideways through space at more than 1,000,000 miles an hour, and the thing pulling it sits hidden behind your own neighborhood, behind a wall of dust we only just learned how to see through. The Milky Way, the giant spiral of stars that holds our sun and Earth and every person you have ever met, is being tugged toward a structure roughly 3,000 times wider than our entire galaxy. We could not see it for more than 100 years. We can finally see it now, and the picture is stranger than anyone expected. If you love being early to real cosmic discoveries, this is the place to be. Hit subscribe and turn on the bell now, because stories like this one drop here often, and the next one might be even bigger. To appreciate how strange this story is, you have to start simple, so that even if you have never looked through a telescope, you can follow every word. Imagine a pancake of stars, gas, and dust about 100,000 light years across. A light year is the distance light travels in 1 year. Light is the fastest thing that exists, but even light takes a full year to cover that distance, and that distance works out to about 6 trillion miles. Our sun sits inside this pancake, way out on one of the outer edges. From far outside, our pancake would look like a glowing pinwheel with bright spiral arms winding out from a bright, packed middle. That pinwheel is the Milky Way galaxy, and it holds at least 200 billion stars, plus Earth, plus you, plus every person you have ever known. Now imagine you are riding inside the pinwheel. You look out at the rest of the universe in every direction. To your left, you see distant galaxies, glowing smudges of light. To your right, more smudges. Above you, more. Below you, more. But straight ahead, right where the middle of the pinwheel sits, everything changes. The middle is packed with thick dust. It is like driving on a foggy highway at night. You can see the lane markers a little. You cannot see anything else. That thick, dusty middle band is what astronomers call the galactic plane. It is the brightest, dustiest part of our home galaxy, and it works like a fog wall that blocks visible light from anything behind it. The farther away something is, the harder it is to see through that wall. So for more than 100 years, when regular telescopes on Earth were pointed straight at the galactic plane, those telescopes saw almost nothing back. The dust scattered the light. The dust smeared the colors. The dust blocked faint stars completely. Astronomers gave that fog wall a nickname a long time ago. They call it the zone of avoidance. The name sounds dramatic, but really it is just a polite way of saying, do not bother pointing a normal telescope here, you will not see much. About 20% of the entire night sky sits hidden behind that wall. That is 1/5 of everything humans could possibly see with regular light, blocked by dust that lives right inside our own galaxy. So picture the best map of the universe that humans have ever built. Galaxies scattered across a dark background like city lights on a dark sheet, but right through the middle of that sheet there is a thick blank belt. That belt is the zone of avoidance, and on every old map the belt was empty. Scientists knew something had to be back there, in the dark. They just could not prove what. This is where the story starts to feel like a real mystery. In the 1980s, scientists noticed something strange on those maps. Our galaxy, and many other galaxies near us, were not sitting still. They were all flowing in the same general direction, like cars on a long highway that we could not see. Something out there in the fog was pulling them gently but firmly, like water running down a drain. Astronomers named that hidden something the Great Attractor. The name is not a metaphor, it really does attract. And here is the spooky part. The Great Attractor sits deep inside the zone of avoidance, in the exact part of the sky we cannot see. The thing pulling our galaxy was sitting directly behind the fog, just out of sight. The Milky Way is moving toward it at roughly 600 kilometers every single second. That is more than 1,000 miles every hour, and we cannot even see what we are coasting toward. One senior astronomer described it as sliding toward a cliff with the fog too thick to see the edge. That image is worth keeping in your head. The discovery we are about to talk about is the edge of that cliff finally coming into view. For decades, a stubborn group of astronomers tried to map the Great Attractor from behind the fog. They used radio telescopes, which listen for radio waves that slip around dust grains almost untouched. They used X-ray telescopes, which pick up extremely hot gas. They used infrared telescopes, which feel heat instead of light. Slowly, piece by piece, a picture started to emerge in the fog. The first big version of that hidden picture was published in 2016, when a team at the University of Cape Town in South Africa, led by an astronomer named René Cran-Korteweg, announced something massive. They called it the Vela supercluster. Why does that matter so much? Because Vela was sitting right where everyone had given up looking. Imagine you are told for years that there is nothing in a certain room. Then someone walks in and announces, actually, there is a hidden city in here. That is about how big this discovery was. The Vela supercluster stretches 300 million light years across space. Our entire Milky Way is about 100,000 light years wide. Vela is roughly 3,000 times wider than our entire galaxy. Imagine 3,000 copies of the Milky Way, end to end, hidden behind a fog we used to walk past every night. And we did not see a single one of them. That was just the first rough sketch. Then in 2025 and into 2026, deeper studies came out. A team combined fresh infrared surveys with updated galaxy counts and measured the Vela supercluster far more carefully than anyone had before. What they found shocked the field. The structure is bigger than the 2016 number even suggested. Earlier estimates put it closer to 130 million light-years across. The newer measurements push it to roughly 300 million light-years. That is more than double. In space terms, that is the difference between the size of a country and the size of a continent. If you only knew the first number, you would think you had the picture. You would still be wrong by a factor of 2.5. And the mass. This is where the number becomes almost impossible to hold. The new study says Vela holds roughly 33,800 trillion times the mass of our Sun. Let me take that number apart so it lands. One solar mass is the weight of one Sun. Our Sun is heavy enough to keep every planet in our solar system in orbit, including Jupiter, the giant of the planets. Now multiply that by 33,800 trillion. Our entire Milky Way galaxy weighs roughly a few hundred billion solar masses. Vela weighs about 100,000 Milky Ways, and almost none of that weight is made of stars you can see in a normal telescope. Most of it is dark matter, the unseen stuff that holds galaxies together by gravity, plus hot gas, plus galaxies so far away their light is too dim to spot. And the distance. Vela sits about 870 million light-years away from Earth. That might sound enormous, and it is, but in the cosmic sense, it is practically next door. The nearest galaxy cluster to us, the Virgo cluster, sits roughly 60 million light-years away. So Vela is the next major structure past our cosmic doorstep, and we just found it. We had been missing it the whole time. Let me pause here. Have you ever wondered, before this video, that something that massive could be hiding that close to us, and we could miss it? Comment below. I want to know how many people are hearing this for the first time right now. Now here's the part of the story most people skip, and I really do not want you to miss it. Before this discovery, scientists had two main guesses about what was hiding inside the zone of avoidance. The first guess was simple and kind of boring. They thought the hidden zone was just a quiet patch of sky, maybe a few scattered small galaxies, nothing special. The second guess was that the hidden zone was full of medium-sized clusters, similar to the ones we already knew about in other parts of the sky, just blocked by dust. Both of those guesses turned out to be wrong. What was actually back there was the Vela supercluster, more massive in many readings than the Laniakea supercluster that holds our own Milky Way. Let me say that again in plain words. The thing our galaxy belongs to, the cosmic family called Laniakea, was supposed to be one of the biggest local structures we knew of. The new map says Vela might be even bigger, depending on which mass estimate you trust. In some readings, Vela comes close to matching the Shapley supercluster, which used to be called the largest galaxy pile we knew. So we now have 2 or 3 unbelievably massive structures sitting near each other, all hiding inside the same dusty belt. That gap between what experts expected and what was actually there is exactly why this discovery matters so much. It tells us our old maps of the universe were wrong in a deep way. We were not missing a few small galaxies. We were missing a slab of cosmic real estate so big it changes the math of how everything around us moves. And we were building our theories of how galaxies drift through space using maps that always had that hole in them. Now that we know what is really back there, scientists have to go back and recheck their models of how the local universe flows. Any number that used those old models will now be redone. Let me walk through the major findings one by one. I am going to lay them out in the pattern scientists use, what they expected, what they actually found, and why the gap matters. First finding. They expected Vela to be a moderate-sized cluster, similar in scale to the ones scattered around the southern sky in clear regions. They actually found that it stretches across roughly 300 million light-years, more than double the first rough estimate from 2016. Why that gap matters. Because the size of nearby clusters is one of the main numbers we feed into models of how the universe is structured. If the cluster is more than twice as wide as we thought, every model that used the old size has to be recalibrated. That work is happening in 2026 right now. Second finding. They expected the mass to be in line with ordinary galaxy clusters, maybe a few hundred trillion solar masses. They actually found 33,800 trillion solar masses, the weight of about 100,000 Milky Ways concentrated in one region. Why that gap matters? Because mass pulls things. That much mass sitting that close to us means our entire local neighborhood is being shaped by a structure we did not know even existed. The flow of nearby galaxies is bent toward it. Even our Milky Way, sitting far across the zone of avoidance, gets tugged by it. Third finding. They expected to find a single neat supercluster, a tidy cosmic city. What they actually found is a messy, layered structure with dense clumps and long filaments stretching out into space in every direction. why that gap matters. Because the messy shape suggests this kind of supercluster does not grow in a simple, slow way. It looks more like a giant river of galaxies than a tidy ball. That tells scientists something new about how matter is pulled together on the larger scales. It also suggests there may be smaller superclusters hiding nearby that we cannot see yet. Fourth finding. They expected the Great Attractor to remain a permanent mystery because the fog wall was too thick to map. What they actually found is that Vela may be part of the answer all along. Some scientists now think the Great Attractor is not a separate hidden object. It may just be the densest inner clump of the Vela supercluster. Others think Vela and the Great Attractor might be two pieces of the same giant flow. Nobody knows yet why that gap matters, because for 40 years the Great Attractor has been the biggest unexplained motion in our cosmic neighborhood. We may now have the first real picture of what it actually is. Here is the moment in the story I want you to remember. In the 1980s, our galaxy was confirmed to be sliding towards something we could not see. In 2016, the first sketch of that something appeared. In 2025 and 2026, the full sketch turned into a detailed enough map to challenge old theories. Now, in 2026, the meaning of that map is still being argued about in real time. This is what a real, alive scientific story looks like. The picture is mostly drawn. The meaning is still being decided. Which brings me to a question for you. Do you think the Vela supercluster is the biggest thing hiding in the zone of avoidance? Or do you think there is something even larger that we have not found yet? I am genuinely curious what your gut says before the next study comes out. Drop your answer in the comments. And if this kind of deep, real space story is what you came for, hit the like button now to help the channel keep going. Let me zoom in on the question I keep getting when I tell this story to friends. How could we miss something that massive, that close to us, for that long? The answer is not embarrassing. It is genuinely difficult because light is a fragile messenger. When light from a distant galaxy travels toward our telescopes, it has to pass through the dusty middle of the Milky Way. That dust scatters the light. It smears the colors. It blocks the faintest stars completely. It is not like fog you can sometimes see through on a good day. For many wavelengths of light, this dust acts like a real brick wall. So how did we finally see through it? The answer is a new generation of cameras in space. The James Webb Space Telescope, launched in late 2021 and now operating for several years, sees deep into infrared light. Infrared is just light, whose wavelength is longer than the red our eyes can see. Infrared can slip past dust in a way visible light cannot, like a soft whisper moving through a crowded room while a loud shout gets blocked. Webb has been mapping the hidden zone in tiny slices, and every time it points that way, it sees more galaxies than anyone expected. Webb is not the only new set of eyes. The European Space Agency launched its Euclid mission in 2023. Euclid is designed to map the shape of dark matter and the spread of galaxies across huge chunks of sky. Even though Euclid was not designed specifically to chase the Vela supercluster, its wide, deep survey catches the same dusty region again and again, slowly building up the most detailed map of that part of the sky we have ever had. And beneath those big space missions, new ground-based radio surveys are counting galaxies by their hydrogen gas, which lights up in radio waves that pass through dust cleanly. Every single one of these new eyes has been poking at the fog wall, and every single poke has revealed more stuff hiding behind it. The Vela supercluster is not an oddity. It is the rule. Every part of the universe we have ever had trouble seeing, the moment we build a better camera for that type of light, turns out to be packed with more structure than we guessed. The lesson is simple. The cosmos is busier than the snapshot we see. We have not been looking at the universe. We have been looking at the parts of the universe our eyes and our older tools can see. Now let me shift the tone. I want to tell you what this looks like right now, in 2026, not what it looked like 10 years ago. Right now, teams of astronomers are running new computer simulations that include the full mass of the Vela supercluster. They are checking how the gravity of 33,800 trillion suns bends the flow patterns of nearby galaxies. They are comparing their new simulations to the cosmic microwave background, that faint glow of light left over from the Big Bang, to see if the early universe can tell us anything about a structure this heavy. They are running models that try to answer a question that sounds almost childlike, but is genuinely deep. Why is there a supermassive clump of mass in this exact spot of the sky, while other parts of the sky look quieter? Why here? Why not somewhere else? Every few months, a new paper appears with a partial answer. Some papers say Vela shows the universe is lumpier than we thought, more clumpy than the smooth averages we use to feed into our equations. Other papers say Vela shows that galaxies do not form in little islands. They form in giant rivers, with the rivers feeding into massive pools like Vela. Still other papers say the existence of Vela might be a clue to something we have not discovered yet. Maybe a new particle, maybe a new force, maybe a kind of matter we have never directly seen, only felt through its pull on the galaxies around it. Nobody has the final word. That is what makes this moment so alive. The map is mostly drawn. The meaning of the map is still being decided by humans, right now, in real time. Let me ask you one more thing here because I am genuinely curious. Have you ever looked up at the Milky Way band in the night sky on a truly dark night away from city lights and wondered what was hiding behind that bright band? Now you know. Vela is hiding there along with a long list of structures we have not named yet. Drop a comment telling me where you were the last time you saw the Milky Way band in person. I will read every single one. Now I want to do something different. I want to zoom all the way out and ask, why should you, sitting in your living room right now, care about a supercluster 870 million light years away? The answer is that you share a universe with it. You are sitting inside a galaxy that is being gently pulled by a structure 3,000 times wider than your home galaxy. The pull is small, so you do not feel it in your body. Nothing dramatic will happen in your lifetime. The universe is too empty for collisions, but the journey is real. Right now, every second that ticks by, your planet, your sun, and every other star in the Milky Way are drifting toward the Vela supercluster at hundreds of miles per second. You are part of that drift. Your whole cosmic address is slowly sliding downhill, even though you cannot feel the slope. And here is the bigger meaning. The Vela supercluster story is not just about space. It is a story about how easy it is to miss something that is right in front of you. The Milky Way is our cosmic home, and we still had a continent-sized hole in our map of the sky. We owed that hole to dust, to old telescopes, to old assumptions. The new generation of telescopes is closing those holes one by one. Every time we close one, the picture of the universe grows, and every single time the picture turns out to be stranger than the one we replaced. That is what keeps people like us watching the sky, even when we cannot see most of it. The sky is not a puzzle with one missing piece. It is a puzzle with hundreds of missing pieces, and we are the species stubborn enough to find them, one by one, sometimes after a 100-year delay. Vela is proof that patience, new technology, and old curiosity still pay off. There will be more Velas. Within the next few years, more infrared data will be released from Webb and Euclid. More radio surveys will map hydrogen in the dusty zone. More supercomputers will run simulations that include the new mass numbers. Somewhere in that flood of new data, there is going to be another surprise. Not just another supercluster, but maybe something even weirder that we do not yet have a name for. And that is the most important point. The universe is still surprising us. Not far away, at the edge of everything. Right here, in our own neighborhood, in the part of the sky we used to call empty. The moment we think we know the answer is the exact moment a new map proves us wrong. That is not embarrassing. That is the joy of studying space. That is the part that keeps people like us watching for the next story. So, what do I want you to do with this video before you go? First, hit the subscribe button. Channels like this one spend real time breaking down discoveries like this so you do not have to read 20 papers to understand them. Second, turn on the notification bell so you know the moment the next big find drops. Third, drop a comment answering one specific question. Tell me this. Do you think we will find something even bigger than Vela hiding in the same dusty zone? Or is Vela the biggest one that was hiding? I want to see what you think. Fourth, share this video with one friend who loves space mysteries. They will thank you, and so will the channel. If you stayed with me all the way to here, I want to say thank you. You just learned more about our cosmic neighborhood than most people learn in a lifetime of casually watching the night sky. Keep looking up, and I will see you in the next one.